Today, I would like to introduce the Safety Goes Digital program to you. This program is focusing on the digitalization of functional safety with added value. The program is made up by 4 pillars. First, safety and security. As there is no safety without security, especially in a digitalized world, this is a very important topic. This pillar reflects on how security solutions can be established, covering the entire safety lifecycle. Second, enduring compliance. Safety compliance is the overall target of all engineering activities around functional safety. This pillar reflects on how compliance can be supported over time. Third, streamline engineering. The engineering processes at functional safety are one of the most important cost drivers. This pillar reflects on how to optimize them by using digitalized methods. Fourth, effective management of change. During operation of a safety solution, changes need to be made, and if no changes are applied, this need to be proven. This pillar reflects on methods and strategies on how to streamline these procedures by using digitalized tools. When talking about such a program, intended to drive digitalization with added value, it's important to not only look at the individual elements of the program, but also important talking about the overall objectives to be achieved. In our case, we subsummed the overall objectives as follows. Flexible architecture. The most individual setups we see requiring a high level of flexibility. At the most of the operators, we find settlements covering what is needed in a more or less effective way. Our aim is not to replace everything we find, but to integrate what is available and optimize the usage so that the cost of functional safety can be minimized while maintaining compliant operation of the individual safety solution. Summarize. Safety Goes Digital by HIMA is a program driving the digitalization of functional safety. It is covering a holistic approach for safety and security. It drives simplification of the demanding tasks of functional safety. It maintains focus on what really creates additional value. And it is made up flexible, allowing to be adaptive based on the individual circumstances. The first pillar of Safety Goes Digital is safety and security. Let's take a closer look at what are the high-level details of this pillar. Talking about safety and security from the operator's perspective. Where's the concept of implementing a security environment for functional safety? We create an offering maintaining compliant operations throughout the entire life cycle at minimized cost. The basic concept is made up by segregating safety and security measures, so both can be handled independently from each other, thus maintaining sufficient flexibility for running safety and security life cycle following the different timing constraints to be applied. The overall solution is scalable, so it can adapt to individual constraints to be taken into consideration. The concept is done in a way that the system aspects as outlined in IEC 62443-3-3 are maintained, delivering a compliant overall solution. Based on these facts, we are able to deliver the following added values to our clients. Based on the segregation of safety and security, the overall complexity will be reduced. Compared to today's practice, the standardized setups for safety and security enabling significant savings potentials for both OPEX as well as CAPEX. The license to operate in view of safety as well as security aspects gets fully maintained. Deviating regional stipulations can be accompanied. All relevant support processes like updates, backups, and data transfers from and to the security environment are covered by the solution we developed. Talking about safety and security from the integrator's perspective. With the concept of implementing a security environment for functional safety, HIMA created an offering minimizing the risk of incompliance while being flexible to adapt to different end users' requirements. The basic concept is made up by segregating safety and security measures, so both can be handled independently from each other, thus maintaining sufficient flexibility for being implemented effectively even under different constraints to be followed. The overall solution is scalable, so it can adapt to individual constraints to be taken into consideration. The concept is done in a way that the system aspects as outlined in IEC 62443-3-3 are maintained, delivering a compliant solution. These facts delivering the following added value to integrators. The security-related processes got globally standardized, so they are suitable, independent from individual constraints. Applying such proven and used procedures allowed to reduce the cost of implementation, but also reduces implementation risks. The security environment conceptual design drives flexible implementation, supporting adaptations according to project-specific constraints. The second pillar of Safety Goes Digital is enduring compliance. Let's take a closer look at what are the high-level details of this pillar. Looking at the compliance aspect from an operator's point of view, the following things are important to be maintained. Throughout the entire life cycle, compliance with standards such as IEC 61508, 61511, and 62443 need to be maintained. If this cannot be achieved, the license to operate is set on risk. Implementing and operating of instrumented system safety functions is a multidisciplinary undertaking. Driving this efficiently requires to make sure the individual disciplines are working as a team and not as interfaced silos only. Implementation, execution, and monitoring of all these processes, making up a compliant management system, is a costly and demanding task. Automating execution and monitoring of the relevant tasks drives compliance and saves cost. All in all, HIMA delivers the following benefits to our clients. Digitalization of the lifecycle activities for testing supports compliance and saves OPEX. Digitalization of the safety reviews mitigate risk of incompliance and saves cost. Digitalization of the safety lifecycle activities enables a continuous improvement process and drives operational excellence. Customers implemented such programs, reporting a reduction of insurance premiums. Looking at compliance aspects from the integrator's perspective, the following aspects are important to be maintained. Throughout the implementation of a project, compliance with the standards such as IEC 61508, 61511, and 62443 need to be maintained. To drive cost reduction of functional safety, such a program needs to be established at all participants of a project. Implementing of instrumented safety functions is a multidisciplinary undertaking. Especially at projects and getting multiple sub-vendors, it's important to eliminate potential silos, as a silo culture may lead to costly errors. Implementation, execution, and monitoring of all these processes, making up a safety management system, is a costly and demanding task. Automating execution and monitoring of design and implementation processes drives compliance and saves cost. All in all, this delivers the following benefits. Digitalization of the lifecycle activities for software generation and testing supports compliance and saves CapEx. Digitalization of the safety reviews mitigates risk of incompliance and saves cost of incompliance. Digitalization of the safety lifecycle activities enables a continuous improvement process and drives design excellence. The third pillar of Safety Goes Digital is streamline engineering. Let's take a closer look at what are the high-level details of this pillar. Looking at the engineering aspects from an operator's point of view, the combination of features and good practices we developed leads us to we have the possibility to seamlessly integrate data gathered from either instrument databases, predefined specifications of either functions or test procedures. The HIMA engineering tools are designed in a way that manipulations on both levels, at the application data but as well the tools themselves, are detected and cannot impact the result of either maintenance or engineering processes. The engineering procedures we developed allowing to support the transfer of information, for instance the functional specifications, into a safe technical function by combining functional information and predefined test specifications. By widely automating the overall engineering process, we minimize the level of manual data handling so that related errors are prevented and costs are minimized. This combination of facts allowed to deliver the following key benefits. The possibility to effectively use predefined templates drives quality and saves implementation cost. Automated test procedures for both logic as well as interconnected devices helps to save cost and reduces production outages. The possibility to train operators using a digital twin allows to more efficiently execute such trainings independently from the implementation of projects. The introduction of automated processes for generating and testing of software minimizes the influence of individual human errors and driving the quality of such implementations. Looking at engineering aspects from the integrator's perspective, the combination of features and good practices we develop leads us to we have the possibility to seamlessly integrate data gathered from either instrument databases, predefined specifications of either functions or test procedures. The HIMA engineering tools are designed in a way that manipulation on both levels at the application data, but as well as the tools themselves, are detected and cannot impact the result of the engineering processes. The engineering procedures we developed allowing to support the transfer of information, for instance a functional specification, into a safe technical function by combining functional information and predefined test specifications. By widely automating the overall engineering process, we minimize the level of manual data handling so that related errors are prevented and costs are minimized. This combination of facts allows to deliver the following key benefits. The implementation risk gets minimized and all processes and tools are designed in a fault-tolerant fashion. Driving efficiency, utilizing the HIMA-specific tools and procedures, reducing time and cost, especially during commissioning of projects. As our procedures and tools are allowing the segregation of hardware and software engineering, this enables the possibility to significantly shorten the implementation lead times. The fourth pillar of Safety Goes Digital is effective management of change. Let's take a closer look at what are the high-level details of this pillar. Looking at management of change aspects from an operator's point of view, the focus is on the operational phase of the safety lifecycle. Based on the features of our products in combination with our safety know-how, our offering is covering the following. A continuous monitoring capability allowing to monitor changes of either the entire project or parts of those is available. Individual elements can be designed, changed and monitored independently from the overall project data. The tools we provide allow to precisely identify both the impact of changes but also the absence of changes, so that the reviewing effort required to be undertaken can be minimized to what got impacted by a change. Virtual pre-testing of logic interface to either field devices or neighboring system is fully supported, so that beforehand having a modification going live, extended testing can be done. Support of automated proof testing of field devices to minimize testing effort and being able to test dedicated parts of the installation without interfering with the rest of the installation is available. This combination of facts allows to deliver the following key benefits to our clients. The risk of incompliance during the operational phase of the lifecycle gets minimized. The possibility of extended offline testing using a digital twin allows to drive quality of changes while helping to minimize cost of the required testing. Also, the training effort for the operator staff can be minimized. The possibility of automated proof testing of field devices helps to speed up and simplify the recurrent testing of installations. Looking at effective management of change from the integrator's perspective, it needs to be outlined that the design and engineering phases of the SaaS lifecycle need to be covered by a management of change process too, as especially during the implementation, modifications happen quite frequently. This is an important factor driving cost and risk in compliance. Based on the features of our products in combination with our safety know-how, our offering is covering the following: continuous monitoring capabilities, allowing to monitor changes of either entire projects or part of the projects. Each project can be segregated into multiple sub-projects, allowing to be changed and monitored independent from the overall project data. The tools we provide allow to precisely identify the impact of changes so that the testing effort required to be undertaken can be minimized to what really got impacted by a change. Virtual pre-testing of logics interfaces to field devices or neighboring systems is fully supported. The support for project implementation includes support of automated proof testing of field devices to minimize the testing effort, especially during commissioning activities. This combination of facts allowing to deliver the following key benefits. The risk of incompliance during the implementation gets minimized. The possibility of extended offline testing using a digital twin allows to drive quality of implementation while helping to minimize cost of testing required. In addition, the implementation lead time can be minimized. The possibility of automated proof testing of field devices helps to speed up and simplify the commissioning of installations.